Welcome, learner, to today's deep dive. Imagine watching a beautifully vibrant plant suddenly sprout brilliant purple and blue flowers.
Right. You probably think you're an absolute gardening genius.
Exactly. You're thinking, I've done it, I've coaxed this living thing into peak performance. But biologically, you're actually watching a plant throw itself a retirement party right before it dies.
Yeah, that visual is pretty jarring.
Yeah.
But it's the harsh reality of plant biology.
It really is.
We're so conditioned to see a flower as a triumph, like a reward for our careful watering and sunlight management.
Oh, totally.
But we forget that for a lot of species, blooming is basically a terminal diagnosis. It's the organism's frantic, last-ditch effort to pass on its genetics before the entire system just shuts down.
Which brings us to the source material for today. It's this highly specific, really fascinating dispatch from a personal gardening journal. It's titled Notes on Gardening, Part 884, and it was published on May 3, 2026 by an author going simply by Ang.
And, that title alone, Part 884, implies just an incredible level of dedication.
Right. That's nearly 1,000 documented observations, 1,000 little tests, failures, and adjustments.
It really shows a mindset of relentless optimization. And what we're pulling from this journal entry isn't just some quirky trick for a houseplant.
No, definitely not.
It's a masterclass in observation, problem solving, and challenging the basic assumptions of how things usually work.
The mission today is to look at how Ang is hacking the life cycle of a very common plant, the Coleus, using a couple of incredibly clever, low-effort propagation experiments.
Right. And the underlying principles here apply to you, whether you have a green thumb and you're trying to save a dying plant, or you're just trying to troubleshoot a failing project at work.
Right.
Or even if you just want to rethink a broken system in your daily routine.
Let's get into the specific crisis Ang was facing in the garden, because there's this beautiful paradox happening here.
Yeah, it's a really interesting situation.
The Coleus plant is sending out a distress signal, but it's disguised as those stunning purple and blue flower spikes we just talked about.
Right.
And this whole situation started with a simple missed deadline. Ang notes right at the beginning of the entry that they missed the window to prune the Coleus in time to harvest its seeds.
And missing that pruning window is a big deal. It triggers a massive biological shift in the plant.
Wait, really? Just missing one pruning?
Yeah. When a Coleus isn't pruned, it eventually hits maturity and it bolts.
Bolting.
It shifts every ounce of its energy away from vegetative growth, which means it stops producing those famous, wildly colorful, velvety leaves it's known for.
Ah, right.
Instead, all those resources are funneled upward into reproductive growth, the flowers.
So the plant is essentially cannibalizing its own aesthetic value just to make seeds.
Exactly.
And the journal specifically notes that once this happens, the plant starts looking scraggly and leggy. The vibrant energy just drops off a cliff.
Yeah, it gets really sad looking really fast.
For most plants, we think of blooming as the grand finale fireworks show, right? It's the peak of their existence.
Usually, yes.
But for the Coleus, it's that retirement party. It puts on this one last colorful hat, immediately stops doing its main job of making beautiful leaves, and just kind of gives up. It clocks out.
It undergoes what botanists call senescence. Basically, the plant is actively programming its own decline because, well, from an evolutionary standpoint, its job is done.
Right.
But Ang's deep observational skills catch a really slight anomaly here. The text notes that despite this clear end-of-life signal, some Coleus varieties are surprisingly resilient.
Oh, wow.
Even while throwing that retirement party, they keep growing new shoots.
So they're stubborn. They've handed in their 2 weeks' notice, but they refuse to clear out their desk.
Exactly. And that stubbornness gives Ang a tiny window of opportunity.
Now, the logical next step for a gardener in this situation might be to just let the flowers go to seed, harvest those seeds, and start completely over next season.
Right. But Ang admits in the journal that harvesting the seeds from this specific variety is an uncertain gamble.
Because I hadn't tried it before.
Yeah, they don't know the viability rate or if the seeds will even breed true to the parent plant's colors. When you're dealing with a wild card like that, you have to pivot to preserve the existing biological line.
Right. So because harvesting seeds was such an uncertain gamble, Ang decides to take cuttings of the scraggly plant and experiment with new propagation methods to extend what they call the Coleus's supposedly perennial lifespan.
They're trying to cheat death.
They really are. And that takes us to Ang's first experimental tweak. Now, the standard procedure for taking a cutting, and I've done this, my grandmother did this, I think, everyone has done this.
Oh, sure.
You snip off a piece of the stem, drop it into a glass jar filled with shallow tap water, stick it on a windowsill, and just hope for the best.
It's the universal default setting for indoor gardeners, the absolute path of least resistance.
But Aang bypasses that default entirely. Instead of going straight into the shallow water, Aang took the cuttings and soaked them in a rooting hormone for a full 24 hours.
A complete chemical bath.
Right. And only after that soak did they move the cuttings into a jar with good moisture and indirect sunlight. Now, I have to push back on this step a little bit.
Okay, let's hear it.
Wait, the old drop it in a glass of shallow water trick has worked for generations of indoor gardeners. Pothos, spider plants, philodendrons, people have been doing this forever.
Sure, yeah.
So why overcomplicate a perfectly simple, free process with a 24-hour chemical soak? It kind of feels like adding steps for the sake of adding steps.
Well, that skepticism is crucial when evaluating any new system. Like, why change what works?
Exactly.
But the answer lies in the physiological state of the plant Aang is dealing with. A healthy pothos clipping is full of vigor. It wants to grow. But remember the state of this specific Coleus.
Right. It's throwing the retirement party.
Exactly. It's in senescence, it's leggy, it's ballooning, its internal clock has already sounded the alarm that its lifespan is over. You can't just put a dying organism in a glass of tap water and expect it to casually reinvent itself.
Ah, I get it now. So the baseline conditions are completely different. The grandmother's pothos isn't actively trying to die, this Coleus is.
Precisely. Aang is fighting a biological shutdown sequence. To win that fight, you need a proportionally stronger intervention.
So the rooting hormone isn't just a vitamin boost.
Not at all. It's a massive chemical override. Most rooting hormones rely on synthetic versions of auxins.
Auxins.
Yeah, they're naturally occurring plant hormones that dictate cellular behavior. When you soak a cutting in a high concentration of auxins for 24 hours, you're essentially hacking the plant's cellular memory.
You're forcing the cells to change their career path. Like you're telling stem cells, hey, you're not a stem anymore, you're a root.
Yes. The scientific term is dedifferentiation. The auxins force the specialized stem tissue to revert back into an unspecialized state and then immediately respecialize into root tissue.
That is wild.
By doing a full 24-hour soak, Aang is basically screaming instructions at the plant's DNA. It's a definitive, undeniable signal. You are not dying today. You are growing roots right now.
It just completely overrides that supposedly perennial nature, making it actually hold up under pressure.
Exactly.
It's a masterstroke of recognizing when a default system isn't enough. The plain water trick is for peacetime. Aang is at war with the plant's biological clock, so they brought in the heavy artillery.
But, even with that incredible chemical override, the plant still faces a massive physical bottleneck.
Right, because the cutting still has to survive in a jar of water for weeks to actually develop those newly programmed roots. And that brings up the absolute biggest threat to water propagation.
Stagnant water.
Yes, stagnant water.
Silent killer of millions of kitchen windowsill experiments.
Seriously.
You see a cutting turn to mush, and you assume, oh, I did something wrong with the clipping process. But it's almost always the water itself.
Well, actually, it's not the water that causes the root rot. It's the lack of oxygen in the water.
Right.
Stagnant water gets depleted of oxygen very quickly, and when the oxygen drops, anaerobic bacteria that thrive in low oxygen environments, they just take over.
And those anaerobic bacteria literally digest the plant tissue,
Yeah.
turning your hopeful little cutting into, brown, foul-smelling slime.
Oh, it's the worst. But that biological mechanism is exactly what Aang targets with the second and honestly most innovative experimental tweak. To combat those anaerobic conditions, Aang repurposed a piece of equipment from a completely different hobby. The journal notes they introduced air bubbles from a nearby aquarium pump directly into the propagation jar.
I love the visual of this so much.
I know, right?
Yeah.
Instead of leaving the poor plant to sit in a stagnant, suffocating puddle, Aang has essentially built a customized luxury jacuzzi for the plant roots.
A VIP spa treatment.
Exactly. And the text specifically notes that this bubbling action was intended to speed up the propagation process and prevent that dreaded root rot.
Well, let's elevate that jacuzzi metaphor a bit, because it's even more mechanically fascinating than just massaging the roots. The bubbler acts like a mechanical lung for the water.
A mechanical lung? How so?
Well, a common misconception is that the bubbles themselves are injecting oxygen directly into the water as they float up.
Wait, they aren't?
No, that's only a tiny fraction of it. What the bubbler is actually doing is constantly fracturing the surface tension at the top of the jar.
Oh, I see. Breaking the surface allows the water to actually breathe.
Exactly. By violently agitating the surface of the water, the bubbler forces continuous gas exchange with the air in the room. Carbon dioxide escapes, and fresh oxygen is absorbed.
Wow.
It keeps the dissolved oxygen levels artificially high. And because those tissue-destroying anaerobic bacteria physically cannot survive in high-oxygen environments, Aang has effectively sterilized the environment without using a single drop of chemical fungicide.
They starved the bad bacteria out by flooding the zone with oxygen.
Yep,
That is just brilliant physics applied to a biological problem.
it really is.
But there's a huge secondary benefit to this aquarium setup that completely changes the human element of the equation.
Oh, absolutely.
The journal highlights that this oxygenated system completely removes the need for constant water changes.
Which is, honestly, the most tedious part of standard water propagation.
Without a doubt, if you're using a plain glass on a windowsill, you have to dump and replace that water every 2 to 3 days to manually replenish the oxygen and dump out the bacteria.
And if you forget, and let's be real, we all forget, the rot sets in.
But Aang completely engineered human error out of the system. With the mechanical lung constantly refreshing the oxygen, the water never goes stagnant.
Right.
The only maintenance required is just topping up the water as it naturally evaporates. Aang turned a fragile, high-maintenance, error-prone process into a robust, self-sustaining system.
And for you listening, this is the absolute definition of working smarter, not harder.
See-
Aang identified the root cause of failure, the anaerobic conditions leading to root rot, and found a mechanical solution with the aquarium bubbles that achieved two goals simultaneously.
Right. It sped up the rooting and eliminated the chores.
Yes, it sped up the desired biological result while entirely eliminating the tedious maintenance chore of changing the water.
And all because there happened to be an aquarium bubbler sitting nearby that Aang looked at and thought, hey, I can use that.
Exactly.
It speaks to the incredible power of cross-pollinating ideas. It's so easy to put our tools and our knowledge into rigid little silos, like this air pump is for keeping fish alive.
Right. But Aang stripped away the label and just looked at the underlying physics. I need aggressive surface agitation to force oxygen into water. What tool do I have that does that?
That kind of lateral thinking is what separates rote procedure from actual innovation.
Absolutely. When you stop looking at the intended use of an object and start looking at its fundamental properties, your toolkit expands exponentially.
Well, let's pull all of this together because the journey documented in just this one short journal entry is pretty wild.
It really is a journey.
It starts with a missed deadline, a missed pruning window that spirals into a biological crisis.
Right.
The Coleus plant hits maturity, shifts its energy into those deceptive, beautiful purple and blue flowers, and begins its inevitable, scraggly decline toward death.
Right, a crisis that forced Aang to abandon the traditional yet uncertain route of harvesting seeds.
And that forced pivot is what sparked two phenomenal experiments to extend the plant's lifespan. First, recognizing that the default glass of water trick wasn't strong enough to fight an actively dying plant, Aang deployed a massive chemical override.
A 24-hour soak in rooting hormone.
Exactly, to forcibly rewrite the plant's cellular instructions, utilizing synthetic auxins to trigger immediate root growth.
Followed by the mechanical hack, building a customized, continuously aerated propagation chamber using an aquarium pump.
That pump fractured the water's surface tension, forced continuous gas exchange, starved out the anaerobic bacteria that cause root rot, and completely removed the tedious chore of manual water changes.
It's just such a rich case study. Aang's approach is a great reminder for you to constantly be auditing your standard operating procedures.
Yeah, just because everyone for the last 50 years has rooted their clippings in a plain glass of shallow water doesn't mean it's the best, most efficient, or most reliable way to do it.
It's just the easiest.
Yeah.
We accept defaults because they require zero cognitive load.
So true.
The plain glass of water is easy to set up, but it has a high failure rate and requires constant manual maintenance. Aang's method requires a bit more thought up front, procuring the hormones, setting up the bubbler, but it results in a near-guaranteed success rate with zero ongoing maintenance.
Sometimes the default setting is just the setting we haven't bothered to optimize yet.
Total.
And that leads to a thought I want to leave you with today. Think about that scraggly, blooming Coleus. It had reached an inevitable biological endpoint.
Right, it was shutting down.
It was literally programmed to die. But that supposed inevitability was completely bypassed with nothing more than a chemical soak and a repurposed fish tank bubbler.
It just proves that inevitable is often just another word for, I haven't figured out the right intervention yet.
Exactly. So look around at your own life. What inevitable endings are you currently accepting?
Mm-hmm.
Maybe it's a project at work that seems destined to fail, a hobby you feel you've outgrown, or a daily routine that has become stagnant and lifeless. Are those things actually at their absolute end? Or are they just waiting for you to challenge the default assumptions, cross-pollinate a weird idea from somewhere else, and apply the right, simple hack to keep them thriving?